So yesterday we looked at a video where we talked about the p-value, and this p-value is going to be different, a different process or a different test, I say, when we have categorical data versus quantitative data. So it really kind of depends on your research question, which one you're going to use. And on your research question, I have this broken down between categorical and quantitative. However, if you chose your own and you approved that by me, then think about what you're going to be recording. Are they going to be numerical, or are they going to be like words, yes or no, things like that? So let's look at analyzing and interpreting data for categorical variables. We're going to be looking at quantitative tomorrow. So after we collect our data and it's time to analyze this data. So assuming we have chose a experiment, observation, or survey. Now that we have that, what's next? We're going to analyze it. So data analysis refers to the systematic application of statistical and mathematical techniques to summarize, manipulate, and organize data in order to uncover patterns, relationships, or trends. When analyzing data, the nature of data you have, categorical, quantitative, plays a crucial role in determining the appropriate methods or techniques of the analysis. So understanding these two categories of data is fundamental to statistics and data analysis because they require different approaches to interpretation. We're going to first look at how to analyze and interpret categorical data. And recall that categorical data refers to information that can be divided into specific categories or groups. If I've got so many typos. It represents characteristics or qualities that can be separated into distinct qualifications like gender, color, or type of car, or yes or no responses. Okay. I have two of the same slides, or part of the same slides. Okay. Or more simply put, data analysis is the process of examining and breaking down the data to understand what it actually tells you. So suppose you are interested in what people do when they sneeze. Do they sneeze into their hand, their elbow? Do they not cover up at all? Or do they just sneeze all over the place and not cover it up at all? Furthermore, suppose you are interested in determining if there was a behavior between gender and how they sneeze. Do guys typically sneeze without covering up while women sneeze into a handkerchief? We're going to call this a respiratory event. And there just so happens to be a study that was done by this. What do people do when they sneeze? By a college professor who sat on a bench during his lunch over an unknown amount of days and observed people's behavior in a respiratory event. First thing we want to look at is when someone sneezed, did they cover up in their elbow, hand, or not at all? He also recorded their gender. The first thing we want to look up is what type of study is this? So we were told that a college professor sat on a bench during his lunch over an unknown amount of days and observed people's behavior. This is just an observation. He didn't do anything to manipulate anything, didn't suggest anything to anybody, and he didn't ask any questions. He just sat there and observed. Okay, so the next thing we want to, I don't know why I have multiple slides of this. So we're going to start by, after we look at what type of study this is, we're going to practice writing a null hypothesis, which, remember, a null hypothesis is stating there is no relationship between our two variables, which in this case, our variables happen to do with gender and how people react when they sneeze. So we can simply say something like there is no significant difference in the behavior of covering up with the elbow, hand, or not at all when sneezing between different genders. So that's what a null hypothesis is. You're going to have to write one, and it's basically taking whatever your variables are. You should have two at least, and saying that there is no difference between those two things. Like, it doesn't matter if you're male or female, and the way you sneeze, you're going to, there's not a big difference. So we're going to start by beginning our analysis with our categorical data by doing the following. First of all, we want to organize the data into a two-way table. We did this back in Unit 8. You guys have practice with that. So you're going to have a big list of a bunch of stuff. We need to organize that and put that into a two-way table. Something like this. So you'll have a big long list of something, and then you'll say, okay, how many women sneezed using their elbow? There's 61. We're counting up all of these different things. And then we're going to put our totals in those as well. So getting this into a two-way table. We also talked about how to create a side-by-side column chart to visualize your data. So we're going to use Google Sheets to do this. And you might want to consider asking the following questions. What surprised you about this data after we put this all together and we create a side-by-side chart? We have the women on the left, the men on the right, and their respiratory events in red, blue, and green. How they chose to cover up their sneeze or not cover it up. What trends did you notice? And what does this data? How does this data relate to what you expected? Me personally, I would probably say guys typically maybe don't cover up as much, and this data doesn't really do that. Women, it looks like a good majority of them use their hand, and that kind of is surprising to me because just women like using their hand and then shaking somebody's hand. I don't know. It's just those are some things that you can do. And then the next thing we're going to do is perform what's called a chi-square test for independence or of independence. And this chi-square test is only for categorical data, and it helps us to see if there's a meaningful difference between what we expect to happen and what we actually observe in a set of data. So when we conduct a chi-square test to compare observational data to what you would expect if there were no effect or relationship, the p-value that we talked about or that you guys saw in the video tells you how likely or the probability you would see the observed differences or something more extreme if there really were no effect. So we're going to perform a chi-square test of independence. This test is going to show us if the differences we observe are likely due to chance or if they are more or might be more significant. In short, it helps us understand if the patterns in our data are really there or if they happen by luck. In statistics, researchers utilize a concept known as the significance level, which represents a threshold for determining whether an observed effect or difference is unlikely to have occurrence by chance. And this level is often set at 0.05, meaning there is a 5% risk of concluding that a difference exists when there is actually no true effect. So I'm going to show you guys what this looks like and pretty much exactly what to write down. Like I want y'all to be able to interpret this, but I'm kind of setting y'all up to be able to do this. And you're going to basically enter in your data and write down like see what that p-value is and then say is this above or below this number and then just basically write what I write, but try to understand what that means as we go through this. When the p-value from a statistical test falls below this significance level, the results are considered statistically significant, indicating strong evidence against the null hypothesis. Remember, the null hypothesis says there is no relationship or difference. And don't worry, I did the calculations for you. All you have to do is this. So we're going to go to the Canvas calendar and click the link for chi-square test. We're going to click and make a copy and enter into the data into the first table. And you need to make sure the size of the table in the Google Sheets match the size of your table by deleting any rows, columns that were not used. Then you need to delete any rows and columns from the expected values that you did not calculate, and then write down the p-value that calculates. Once we have that p-value, we're going to compare that to the 5%, and I will click on this link real quick, and so we can watch that. Oops, wrong thing. Here's a little video over the p-value.
Your life is your choice. So if you feel stuck, choose to get an accounting fundamentals certificate from WG. Understanding the p-value. One of the important concepts in statistics is the meaning of the p-value. Whenever we use Excel or other computer packages to analyze data, one of the key outputs is the p-value, or sig. In formal terms, the p-value is the probability that, if the null hypothesis were true, sampling variation would produce an estimate that is further away from the hypothesized value than our data estimate. In less formal terms, the p-value tells us how likely it is to get a result like this if the null hypothesis is true. We will now go through this step by step with an example. Helen sells chocolate. Recently, she has received complaints that the chocolates have fewer peanuts in them than they are supposed to. The packet says that each 200-gram packet of chocolates contains 70 grams of peanuts or more. Helen can't open up all the packets to check, as then she wouldn't be able to sell any. So she decides to use a statistical test on a sample of the packets. The null hypothesis, often called H0, is the thing we are trying to provide evidence against. For Helen, the null hypothesis is that the chocolates are as they should be. The mean or average weight of peanuts in the packet is 70 grams. The alternative hypothesis, called H1 or HA, is what we're trying to prove. The customers have complained that the weight of peanuts is less than what it should be, so the alternative hypothesis is that the average weight of peanuts is less than 70 grams. Helen decides to use a significance level of 0.05. If the p-value is lower than this, she will reject the null hypothesis. Having decided on her hypotheses and on the significance level, Helen takes a random sample of 20 packets of chocolates from her current stock of 400 packets. She melts down the chocolates and weighs the peanuts from each packet. If all of the values were lower than 70 grams, with a mean of 30 grams for instance, it would be quite obvious that the bars did not have the required number of peanuts. It is very unlikely that you will get 20 packets with a mean of 30 grams if the overall mean of all the packets in the population is 70 grams. Conversely, if all the values of the 20 packets were much higher than 70 grams, it would be obvious that there were enough peanuts and that there was nothing to complain about. However, in this case, the 20 packets contain the following weights of peanuts, and the mean is 68.7 grams. This caused Helen to ask herself, does this provide enough evidence that the bars are short of peanuts, or could this result just be from luck? She asks her brother to use Excel to find the p-value for this data, comparing with a mean of 70 grams. The p-value is 0.18. Judging from the data that we have, there is an 18% chance of getting a mean as low as this or lower if there is nothing wrong with the bars. That is, if the null hypothesis is true and the mean weight of nuts is 70 grams or more. This p-value of 0.18 does not provide enough evidence to reject the null hypothesis. In this case, Helen does not have evidence to say that the bars are short of peanuts. This is a relief. The smaller the p-value is, the less likely it is that the result we got was simply a result of luck. If the p-value had turned out to be very small, we then would say that the result was significantly different from 70 grams. In general, we start by saying that the null hypothesis is true. We take a sample and get a statistic. We work out how likely it is to get a statistic like this if the null hypothesis is true. This is the p-value. If the p-value is really, really small, then our original idea must have been wrong, so we reject the null hypothesis. P is low, null must go. A small p-value indicates a significant result. The smaller the p-value is, the more evidence we have that the null hypothesis is probably wrong. If the p-value is large, then our original idea is probably correct. We do not reject the null hypothesis. This is called a non-significant result. The p-value tells us whether we have evidence from the sample that there is an effect in the population. A p-value less than 0.05 means that we have evidence of an effect. A p-value of more than 0.05 means that there is no evidence of an effect. Sometimes a significance level different from 0.05 is used, but 0.05 is the most common one. Disclaimer. This video uses plain language to get difficult ideas across. Some terminology might be viewed as incorrect by a religious statistician.
Okay, let's. So there's a lot of information in there, and a lot of stats classes might go into more detail. But I'm going to kind of show y'all what it looks like on your end, and I'm going to make up numbers because I don't really remember what the numbers were for this. So let's go back to the sneezing thing for, let's see what I have in here. Okay. So this is going to be a little bit different than what mine are. Well, I'll see if I can go back to this. What I need to do is so when you're doing, if you're doing a categorical variable study, then once you have your two-way table, this is what we're going to do. Let me get to that. I'll pull this over here, and then I don't want that. What do I want? Okay, so in order to use the chi-square test, I need to have my two-way table pulled up. So I'll go ahead and do this real quick. So we're going to go to the calendar, which looks like that. And then I'm going to click on the chi-square test for today because we're dealing with categorical data. And you'll get something that looks kind of like this. Let me, so it has all this stuff in here. For starters, we have a elbow, hand, and no cover. So I'm just going to enter this stuff in. I don't need to worry about calculating totals, but I'm going to enter in my men and women. I don't need to rename these categories. This is just for my test. So I'm going to type this in exactly as I see it, but I'm not going to type in any totals. Notice 86 right here correlates to this 86 down here. It already calculates my totals for me. I'm going to do 139 and 49. And here I'm going to do 75 and 43. So I'm just typing in my table. And what I want to do is, after I'm done with this, I want to delete any unused rows and columns. So notice I didn't use anything. I didn't have any columns that exceed like the fourth column. My totals are calculating. I'll scroll over so y'all can see this. See how this is 275, that's 275, 117, 3. I don't have that other stuff yet, but I'm going to go ahead and delete by right-clicking and deleting any unused rows and columns. And if you mess up, you can always go back through and click on that again. You don't have to save this. I'm going to delete any unused rows and columns by right-clicking on them and making my two-way table have as many rows and columns as what I actually have. So notice I have all my rows and columns with my totals. They should match. Then I also need to make sure that I go over here, and where you see this hashtag REF, we also need to delete those columns as well. So columns are the vertical ones. Clear that column, and then clear this column. And then I'm going to go back over here. Okay, so I went through and I deleted those other columns. And so now everything matches. This is expected counts. You don't need to worry about that a whole lot. This is part of what we need to be able to calculate the p-value, which is why it's on the spreadsheet. But what we need to focus on is this this p-value right here. And I also, if you notice in the video, it said 0.05. That's 5%. I just went ahead and put these as percentages on here and changed all the p-values instead of 0.05 to 5%. So what we're doing is we're comparing this p-value to 5%, and all we really need to do is part of your interpretation of this p-value is writing down what we have down here, what says write this. So if you remember that p-value video that we just watched, it said we assume the null hypothesis is true. So this p-value is telling us what percent chance of the null being true. So if I calculate the p-value to be 15.26%, then we would say there's a 15.26% of chance of the null being true, which means there is no relationship between the two variables we're looking at in terms of gender and how somebody sneezes. And so then we would look at that and say, okay, which one of these other things am I going to write after that? Is it going to be A or B? Well, 15.26 is greater than 5%, so I would be writing this B part. So there is a 15.2% chance of the null being true. So since 15.26% is greater than 5%, we fail to reject the null hypothesis, which means that we do not accept it, which the null hypothesis, remember, says there is no relationship between the variables. And if we fail to reject it, I'm sorry, I said that incorrectly. Um, we fail to reject the null hypothesis. This means that the evidence we collected is not strong enough to conclude that there is an effect, difference, or relationship that is statistically significant. And that's all we need to write about this. So you're going to enter in your information on here, and then that will be your interpretation. You're going to add that on a slide somewhere in your presentation. All right, let's move along. Okay, so if our p-value is greater than 5%, we fail to reject the null, which means we accept the null, which means we agree with what the null hypothesis says. Fail to reject means we agree with the null hypothesis. So think about this as a courtroom, like innocent until proven guilty. We don't say that they are like we don't say that they're innocent. We say they're not guilty. So we fail to reject the null would be the not guilty, and then we reject the null would be guilty. Um, so if our p-value is greater than 5%, we fail to reject the null, which means we agree with the null, which says that there is no relationship between gender and the how somebody sneezes, what they choose to do. Using the significant level of 5% and comparing that to the p-value that was calculated, we want to interpret the p-value. So this is kind of something we might say. There's a 15.26% chance of the null being true since 15 point, and this is just basically copying it down from that spreadsheet. Since 15.26% is greater than 5%, we failed to reject the null. This means that the evidence we collected is not strong enough to conclude that there is an effect, difference, or relationship that is statistic or significantly significant. I think I'm supposed to say something different there. Statistically significant. Okay, almost done. And yes, this is an interpretation of this. And yes, I want you to write down this whole thing. This is part of your project, so you need to be aware of how we can interpret this stuff. I'm trying to help you write this stuff as you get your p-value. So yes, you need to write this entire thing down. All right, let's look at another example. This is your turn. I want you to try to use this to be able to answer this. This is on the topic of does profiling occur at airport screening sites? So suppose a rights group wants to determine whether profiling occurs at airport security screening sites. The group collects data for 1,000 randomly selected passengers and classifies their name as foreign or not. So meaning, do they have a name like Smith or Jones, or do they have a name that is not Smith or Jones that appears to be from another country? Then they check to see whether they were fully searched. Let's see if we can write a null hypothesis, find the p-value, and write an interpretation of the p-value. I'll give you all, if you're watching this video for the first time, you need to get comfortable with this. Pause this video for the second, and then we'll see if we can figure this out. So a null hypothesis, remember, says that there is no difference. So we can say that there is no significant difference in the likelihood of being fully searched between passengers classified as having a foreign last name and those classified as having non-foreign last names at airport security screening sites. The p-value that I found on this after I typed in all my data, deleted my unnecessary rows and columns to match my two-way table, was 3.82%. And so my interpretation of this is there is a 3.82% chance of the null being true. Since 3.82 is less than 5%, we reject the null, meaning we do not agree with there not being the null says there is no the null says there is no difference, there is no relationship, that everything is as it should be, meaning that if you have a foreign last name or you don't, there's no difference in you being screened. So therefore, we reject the null, and which means we disagree with that statement. The null is false, and therefore the significant evidence to suggest that there's a meaningful effect, difference, or relationship present in the data. This implies that profiling may, in fact, occur. And that is our categorical data for analysis and interpretation.